Okay, so on this one, on the linear programming, let's look at the problem one more time. It says a toy manufacturer makes rocking horses and dollhouse. So in this example, if you're a corporation, this one you're only making two things. And think about the corporations that produce multiple items. Okay, the warehouse can hold supplies to make at most, I would underline that, it's keyword, at most 600 rocking horses or 800 dollhouses per week. The company makes a profit of $15 on each rocking horse and $30 on each dollhouse. It takes 3 work hours to assemble a rocking horse and 4 work hours to assemble a dollhouse. The company has 3,800 work hours a week available for assembly. And basically that's saying, okay, this is how many employees we have, 8 hours a day, how many work hours do we have per week. It takes 1 work hour to paint a rocking horse and 4 work hours to paint a dollhouse. The company has 3,300 work hours per week available for painting. Use the given data to determine the number of rocking horses and dollhouses to maximize the profit. So if, like, consider this as your family-owned business. How many of those do we make so that we make the most money? Okay? So on this one, and you may need an extra sheet of paper, or you can write on the one you've got. Okay, they're already starting out. X is the number of rocking horses, and we're trying to figure out how many of those do we make. And Y is the number of dollhouses. Okay, so go back to the work hours for assembly. Total, how many work hours total do we have? 3,800. So, and for each rocking horse, takes how much? 3 hours. So 3 hours per rocking horse, so you'd multiply those together. Okay, and each dollhouse to assemble, 4, so plus 4y. And we can't go over the 3,800, so that's less than or equal to. Okay. Okay, then on the painting, work hours for painting, total 3,300, and for the rocking horse, how much? 1, so it'd just be 1x plus 4y. And same thing, we can't go over that because we only have so much labor. Okay? Okay, now we're going to do this on the calculator. So take both of those equations and solve for y. You got to get y by itself first before you can put it in. Okay? And remember, on inequalities, if you multiply or divide by a negative, you have to reverse the arrow. In this case, we're dividing by a positive, so the arrow's okay. And I'm going to go ahead and change this to decimals. The 3/4 should be the same thing as 0.75. And if you take 3,800 divided by 4, I get 950. You agree with that? Okay, so that's one of them you want to graph. So put in a negative 0.75x. Plus 950. Okay, and that gives you a little bit to tell you what the window is. The y has to go up because it's crossing the y-axis. Y equals mx plus b. It's crossing the y-axis at 950. So if we graph that, you're probably not going to see anything. It's way off the window. Okay, solve this for y so that you can put it in the calculator. 4 divides into both of them, and that would be like a negative 1/4 or a negative 0.25x. And then 3,300 divided by 4, I get 825. Okay, so put that in y sub 2. Put in a negative 0.25x plus 825. Okay, and for right now, let's go ahead and do on the window. We know we need our y max. Let's go at least to 1,000. And I'm going to do the y min at negative 100, just so I can see the points of intersection. And the y scale, I really don't care about the tick marks, so turn the tick marks off, make that y scale 0. Okay, and for the x, we'll get to that in a minute. Okay, so now we've got that part. Two constraints of the equations are x is greater than or equal to 0. We could actually make 0 rocking horses or 0 dollhouses. We could say, to maximize our profit, maybe don't make one of them. That's a possibility. Okay, so x is greater than 0. Okay, vertical line at 0. Y is greater than 0 and greater than to the right. Okay, now write the other 4. Well, we've actually written 2 of them. This is a constraint and this is a constraint. Okay, so we need 2 more. Go back up that second sentence. The warehouse can hold supplies to make at most 600 rocking horses. At most means you can't go over that, right? So at most 600 rocking horses. And the rocking horses were the x value. So how would I graph that? Yeah, that's the other constraint. X is less than or equal to 600. And actually the other one was greater than or equal to 0. So we can combine that. That's 2 vertical lines. Okay, then on the y was greater than or equal to 0 and less than or equal to 800. So that's another. So those are actually our 4 constraints. Okay. So now we want to get a graph. Okay. So that tells you a little bit. Our x has to go over at least to 600. I'm going to go bigger than that. On our window, our x min, I still want to see some of that. So let's go negative 100 for right now. We can adjust this. X max, let's go at least 700. And x scale, let's go 0. So on the x, on the window, I'm going negative 100 to 700, and the scale 0. That turns off the tick marks. For the y, I'm going negative 100 to 1000, and I may want to adjust this and turn off the tick marks. Okay, I cannot put in a vertical line, okay, because it's always y equals, but I can put in y equals 800. Okay, so in y sub 3, put in the 800 and graph. Okay, here's our first one. That's crossing at 950. Okay, that one's crossing at the 825, and then the horizontal line is at 800. Okay, so draw, and I'm going to enlarge this a little bit. Draw a sketch of this. Okay, so we had one that crossed. This one crossed, and this was the first one. This was the y equals a negative 0.75x plus 950. So it crossed up here at 950 is this y value. And the other one, you may need to turn off the y sub 3, the 800. Just graph that other one for a minute so you can see it graph. So it went below and crossed, something like that. Okay, and that was our y sub 2, and that was the negative 0.25x plus 825. Okay. Okay, now put in the, and if we were graphing these are less than, so far our intersections, like right here, our convex polygon we're looking at is right here, but we're not done. So now put in that y sub 3 and see if you guys have the advantage on some of those. You have the color, so if you can change the color to see. Okay. Okay, so it actually went below. It went below this one and above. Looks something like that. And if you're not sure, you can zoom in and zoom out. I'm going to do, let's go zoom memory. Zoom on the top row. Zoom right arrow over to memory and do a zoom store so I can always get back to this. Okay. And for right now, let's do a zoom. I'm going to do a zoom box. I'm not sure. Have you guys done zoom box before? On zoom box, it gives you a cursor. You're going to put the pin in the upper left-hand corner. And I actually want to zoom into this. I'm going to get my cursor over. I'm going to get my cursor about to right here. Okay. Press enter. And then use your right arrow. You should see part of the box coming. And I want to see this part. And use your down arrow and press enter. So I'm putting a box. I'm putting a box down arrow, so I'm actually putting a box right around in here. Okay. Okay, so does it look right? Yep. Okay. Now if we did all the shading, okay, the only other part we need is the x. The x is greater than or equal to 0. Okay, so that would be from here to the right. And the other part we need is the x is less than or equal to 600. We can't just graph that, but I can get back to it. I know now that this part's right, how I've got that graph. Okay, so let's get back to it. Do zoom and right arrow over to memory and do a zoom recall. That'll bring back our original graph. So do zoom and then do zoom recall number 3, and you should get back the original graph with the original window. Okay, and now the only way you can tell where your x is 600 is do second function calculate right above the trace key and do value at x equals 600. Okay, and it kind of tells you where you're at. So over here there is a vertical line at x equals 600. Okay, so now we have, if we went through all the process and shaded all this, we have our convex polygon. Okay, right here. Now, if there is a max or a min to the profit, it has to occur at one of those vertices. So what we have to do is go through, we know this one is 0, 0. Okay, this one we should know is 0 to the right and up 800, right? Now we got to figure this one. That is the intersection of the 800, okay, the horizontal line, and the y sub 2. Okay. Now, it will probably be better to go back to either zoom in or zoom box. Okay. Let's go get your cursor back. Put the trace down. Get your cursor back closer to that point. It's too hard to do it without actually being able to see the picture very good. So let's get it close to this. We're going to get it close to this area right here. Get it close to this area right here, and then just do a zoom in. And zoom in. That might not be enough. No, there it is. Okay. Okay, so let's find that point of intersection. Do second function calculate. Intersect. Okay, and the cursor jumps vertically from one equation to the other. So That's not the right equation, so you got to use your down arrow and get it close to this point of intersection. Press enter, press enter, press enter. You should get that intersection is 100. This is 100, 800. Okay, now you got to find this point of intersection. That is the point of intersection between the original two lines. Okay, so we need to get down there. Put your trace key on. See if you can get down closer to that point of intersection. And looks like we're going to have to go back. Just go back to zoom memory and zoom recall. You got to get back to the original graph. There's the two. Okay, find the point of intersection. Okay, so we want this point right here, but this cursor jumps when you do. So do press enter. Okay, I'm on the first. I'm on y sub 2. Okay, second. You're gonna have to use the up arrow. Hang on, you gotta do it again. Second function calculate intersect. Okay, there's column y sub 1. Press enter. Y sub 2. Press enter. Yes. Press enter. Should be 250. So this point is 250 and 762.5. Okay, then we need this point. Okay, and that is the at 600. Do second function calculate value at x equals 600. Okay, and that is the bottom one. So 600, 500. Okay, and this one is 600 to the right and up 0. Okay, so now we've got our, so you might have to do second function calculate intersect. You might have to do second function calculate value. You might have to zoom and store your original graph so you can get back to it. Okay, so now we're down to found the graph. Now we're down to write the equation for profit. Okay, go back up. What does it say about profit? How much are you going to make on a rocking horse? $15. So, and I'm using P for profit. Profit XY. So you're going to make $15 profit for every rocking horse. That'd be 15 times X. Plus, for the doll houses, 30 times Y. Okay, so now we have to go all the way around like we did on the calculator yesterday. The 0, 0, you're not going to make any profit. Okay, so do the 0, 800. Okay, so let's go through that on the calculator. Go back to the home screen. Okay, and put in, we need 15 times 0 plus 30 times 800. Okay, and that gives you $24,000 profit. Okay, go. I'm just going around the horn here. Do 100, 800. So do second function entry. It's right above the enter key. And you're going to have to use your insert key. Remember, it's up here on the top, right above the delete key. Do second function insert and insert a 10. Okay, so that would be 25,000. $25,500. Okay, and then we need the 250. Okay, and here you need to stop. Can you make half of a? Can you make half of a rocking horse or dollhouse? Do so. Do you have enough to make 763? No. So you got to round this back. This has got to go back to 762, right? So 15, 250, 762, 800. Do second function entry. So change that to 250 and 800. Wait a minute. 762. I need 762 there. Wait, I said that. I wrote that wrong. Hang on. This one should be what? 30 and 762? Does that look right? Okay, so that's 26,610. Okay, and then we need 600, 500. Do second function entry, 600, change the 250 to 600, and 500, change the 762 to 500, I get back to 24,000 profit. And then 600, 0. And you're back to 9,000 in profit. Okay. Okay, so there's a wide range. You can go anywhere from 0 profit to 26,610. Okay. Any point in here, okay, is going to be satisfy all the equations or inequalities. Okay, but if there is a max or a min, it has to be at the vertex because of the vertex theorem. Definitely this is the max, 26,000. Okay, so the maximum profit earned is when you have, and this one, the dollhouses was the Y, right? Dollhouses was the Y, so 762 dollhouses and 250 rocking horses, and the profit. And even like, you know, 24,000, 26,000, you know, you guys like buying little things like iPhones and different things, okay? You know, $2,000, you know, you can adjust what you're making so that you make more profit, okay? Around this area, I would say that deals with farming a lot, okay? A lot of farmers, they raise wheat, they raise corn, they raise soybeans, they raise, you know, milo, whatever. But how much is it going to be to maximize their profit? How much labor do they have? How much fertilizer do they need? Same idea. I can tell you, like I said at the beginning, the people that do this are the ones that make the big bucks, okay? The other people are the laborers. They would be the ones who, you know, construct it and paint it, but these are the people that say, let's make this amount so that we make $26,610 profit. Okay? Okay, that should finish up your notebooks. Okay? You need to make sure that you've done all the matrices problems. If you need to finish any of those up, those worksheets, you need to make sure that work is attached in your notebook. So go through that list. Okay?